Hi, this is Mr. Shumway. This video clip explains how to find the equation that best fits data points, a line of best fit. Here's an example of some data points that don't fit a line exactly, but if we try to have about as many above the line as we have below the line, then we can probably still use the line to predict what's going to happen as the data continues. So if this dotted line matches that data fairly well, we can say, well, here's one that's right on a grid and looks like it's headed right for 0, 60. So we went from 60 down to negative 40. That has a distance of, I have to go 60 to get to 0, and I have to go 40 more, so I've gone 100. Y has changed 100, it's gone down 100, and how much did X change in that same amount of time? Well, it went to 20. So from 0 to 20 is a change of 20. So 100 divided by 20 is 5, and it's negative. Negative 100 divided by 20 is negative 5. So we could write the equation y is going down compared to x, and it's going down 5 times as much, so it goes down 5 for every x. We don't know what crosses the y-axis, but we could read it off because we can see that it's going to be about 60. So negative 5x plus 60. But I want to show you another way how to get that without, if it isn't easy to read off of the graph. We could plug in a point that we're pretty confident about, and that would be this one right here where we say it's about x is 20 and y is negative 40. So I could, into this equation here, we could replace y with negative 40 and x with 20. And we still read that as b. So negative 5 times 20 would be negative 100. So solving that, I add 100 to each side. That is 60. So that's the generic way to get that for any equation. Let's look at another example. Let's find places that are right on a grid. There we go, there's 2 of them. If that line fits that data fairly well, there's some above, some below. Yeah, it fits fairly well. So we went from 50 to 150. So the change is 100. So we've gone up by 100. And x has changed from 10 to 20. 20 minus 10 is 10, so got up 100 in y when x changed by 10. Well, that's 10 times as much. So the way that we write that y is changing 10 times as much as x is like this. Y equals 10x. Plus it crosses the y-axis somewhere. Looks like it's headed for negative 50. Let's go ahead and plug in maybe 10 and 50 and see. So 50 equals 10 times 10 plus b. So 100 plus b equals 50. So if I subtract 100, that gives me negative 50 equals b. And so that, just looking at it, saying it's about negative 50, well, we plug it in and it turns out to be negative 50. And so our equation is y equals 10x minus 50. We think that line fits that data the best. It's not a perfect fit, but it's the best fit.